I've downloaded 5 CSV files from the National Built Heritage Service that represent the national inventory for architectural heritage in Ireland. And I'm going to use ArcPy to merge these 5 files together and output as a feature class in a file geodatabase. Now, each CSV has coordinates. In fact, they have 3 sets of coordinates for Irish Transverse Mercator, Irish Grid, and WGS 84. So I'm spoiled for choice for what coordinate system I want to use. So let's check it out. Up top, we are importing ArcPy and Glob. Glob will just help us to grab the file paths to the CSV files. There's a handful of user inputs. We have a folder that contains the CSV files. So I'm going to create a variable called CSV folder. That is the path to that folder. As we're going to create an output feature class, we need the workspace path to add the output dataset to. I'm going to set WS for workspace to be a file geodatabase. We also need to name the output feature class. I will assign the name of the output feature class to a variable called outFC. CSV files have coordinate fields. I actually have a selection for mine for Irish Transverse Mercator, Irish Grid, and WGS 84. I'm going to use the longitude and latitude of WGS 84. So I'm going to set the X field to longitude and the Y field to latitude. And then I need to supply in WKID for those coordinates, which is going to be 4326. Now we move on to the actual workflow. We're going to set the environment workspace to be the input workspace from the user. Here I am using a file geodatabase. Then we get a list of all the CSV file paths, and we're going to use glob. So glob.glob, and we'll use string formatting to put in the CSV folder, and then we're looking for all files that end with .csv. This will return a list of CSV file paths that will assign to a variable called CSV files, and we can optionally print the CSV file list to screen. I will do that for this example. We then use the merge geoprocessing tool, where we set the inputs to be our CSV file paths list, and we're going to use the memory workspace for our output. This will store the merged table in memory and not write out the disk. Now you could output the disk to check for errors, and I'll show you what I mean when I run this script. Optionally, we can also print out the number of records in our in-memory table. So I'll assign the calling of the merge geoprocessing tool to a variable called temp table. We're then going to use the XY table to point geoprocessing tool, where our in table is our merged temporary table. Our out feature class is the outFC as defined by the user. We set our X field and our Y field. For me, it's going to be longitude and latitude, and we set the coordinate system, which is going to be 4326 for WGS 84. I always like to clean up the memory workspace, so I call the delete geoprocessing tool and delete the temp table, which is the merged CSV files. I'll run the script. I can see here the list of 5 CSV file paths that were fed into the merge tool. The merged table had 43,322 features, and we then got warnings when we were using the XY table to point tool. Some of the features have invalid geometry and been removed from the results, and we can see that there are 5 of them there. This is where outputting the merged table to disk could help. There's also a warning there that the row contains a bad value, that field length exceeded, and there's some information about that failure. I'm going to head over to ArcGIS Pro and check out the result. Over in Catalog, I'll click into my databases and into the file geodatabase where I sent the output feature class. I'll have to do a refresh. I can see the heritage NBHS NIAH point feature class here. I can right click and add to current map. If I right click on the layer in the contents and open the attribute table, I can see I have 43,317 records. So there was issue with 5, and this would match the 43,322 that we got from the get count in our script. Now I've simply downloaded these CSV files from a website. I didn't perform any checks or data engineering on them. I simply took them at face value. But you can see how quick and easy it is to use ArcPy to go from a flat CSV file to spatial data in ArcGIS Pro. Make sure to check out this playlist up here for more ArcPy workflows, and make sure to also subscribe. Take care.